I will be talking about the development of an air operation extension with the future C2SIM standard that is to be balloted in the near future. Here's an overview that is more extended than my Vienna talk. Well, I will first talk about the COMELEC project that provides the use case for the air operation extension. And then I will talk about the C2SIM context, because the C2SIM is to exchange or to exchange two different standards, the MSDL and the CBML, to exchange messages and information between systems. Then I will talk about the C2SIM point of use, because there are more than one. And I will talk about the role of ontologies in the C2SIM context. For that, I will explain the core ontology. Then I will go into the standard military extension and explain also a land operation extension, which are all presuppositions for our air operation extension. Then I will also talk about a second use case that we had in the COMELEC project, and it is the land operation extension with UAVs. So actually, this is not a separate extension, but we provide some explanations how the standard military extension and the land operation extension could be extended. After that, I will also talk about other possible extensions and reasoning capabilities that come with ontologies. And well, in the end, we want to get a schema out of the ontologies. So I will also talk about that process. And I finally will talk about some lessons learned and a conclusion. So the COMELEC project that provides the use case for the air operation extension is the abbreviation for a German-French C2SIM working group, which is a subgroup of the MSG 145, and it is also the short term for the current project of that group. Members are on the French side DGA, Airbus, and DGNext, and on the French and on the German side we work with IABG together. The systems that we use for our use case are the C2 system, C2LG GUI, that is provided by Fraunhofer FKE. And on the simulation side, we have 3 different systems depending on a domain, meaning that for land operations, we can use SWORD, for joint operations, CORA, and for air operations, direct CGF. And the simulation systems are to exchange information with the C2 systems. So as Mark already said, I gave that talk also in Vienna, and this is still work in progress. So we will have final results probably next year and presented at the SIW in Orlando. So concerning the C2SIM context, there's the CISO C2SIM PDG that is developing a C2SIM standard, and the CISO C2SIM simulation interoperation has always been supported by NATO activities, currently the NATO MSG 145, that aims at operationalizing the standardized C2SIM interoperability. So far, the standards that we want to exchange are the MSDL standard that was used for initialization, and the CBML standard for the exchange of military communications, such as reports, requests, orders, and so on. So currently, the CISO PDG develops a new C2SIM standard, since the cooperation of MSDL and CBML turned out to be difficult. So the goal is an integrated solution. And the new standard is supposed to be extensible for different domains. Therefore, a group of the PDG developed a military land operation extension. We, in the COMELEC project, are working on the air operation extension, but we wish to get a military maritime operation extension as well. So the C2SIM standard is to be represented as ontology, also because of the extensibility. And each extension should be modeled as separate layer. And depending on the application that you want to use, you can stick different layers to each other and merge all the layers into one ontology so that a tool can generate automatically a schema out of that. So the C2SIM has 2 points of views from the system side, because C2SIM combines command and control systems and simulation systems on the other hand. And the simulation view focuses on military entities and their situation, and also on the realistic order of events and actions. And these actions refer back to doctrines of simulated entities or units. The C2 system view, on the other hand, focuses on commanding simulated units. So the command and control process and its realistic order of events is the focus. So, and C2SIM is a very important field, as it enables education of military leaders in a very cost-effective and resource-conserving way. And also because some maneuvers can be practiced that are difficult to be played in reality. So the interoperability between those systems and the doctrines is very important. From the simulation view, as I just said, the units and their situation are the main parts that they want to have modeled. And this was also the case in the MSDL standard. And just to give you an impression, there are some definitions of entities, and entities are defined as having static and dynamic and states to be defined. And it's like entities are defined by if they are friendly, hostile, or affiliated, which are static attributes. And dynamic attributes would be the location, orientation, health, and speed of entities. So from the C2 view, a main focus is on military and non-military communication, and not just the capability of communication, but also some linguistic aspects, like from the speech act theory, because message types come with specific intentions that a sender wants, for example, like if you have orders or requests, which are directives, so the sender wants the receiver of a message to act in a specific way. And reports, it's differently, because the intention from the sender is just reporting and informing the receiver of a message. So the intention of a message also comes with a specific choice of words and phrases, and also with expectations about a reaction or an answer to orders and reports, for example. So the FIPA model, for example, says that orders need to have an acknowledgement. So we model these ontologies to get to a schema, and also ontologies and schemata provide 2 different point of views that have to be harmonized. So ontologies represent knowledge, and schemata allow the exchange of messages. And good ontologies represent knowledge correctly, which refers back to semantics, and good schemata transmit their messages in a correct form, which refers back to syntax. Therefore, in the C2SIM case, schemata need to refer back to ontologies, and we generate the schemata automatically out of that ontology. as it is explained in the paper by Blaze AI. And we had also evaluation criterions that were a question that can the schema generated out of the ontology core plus air operation extension handle the message exchange as intended? And does it also work if we extend the ontology with our air operation extension? So as we want to get to a schema, I will also talk about some basics about ontologies. And ontologies are formal knowledge representations of classes. Classes refer to concepts of entities, and individuals are instances of classes, as well as attributes and relations of that classes. So semantic concepts of a domain are subdivided into classes, and semantic concepts and their members are related to each other. And these relations are of type hypernymy or hyponymy, like a tank is a vehicle that shows a taxonomic relation, but there's also meronymy or metonymy, like a tire is part of a vehicle, but you can define properties in the way that you want. So as I just said, classes represent concepts that are subordinated to each other, and the subordination of classes allow inheritance. The instances are unique members of the classes, and instances and classes can belong to more than one subclass. Like a tank can be an actor entity or an equipment of a unit. Object properties relate instances to each other, and those instances can belong to different classes. And data type properties relate instances of a class to a data type, such as string, byte, integers, and so on. And restrictions define classes with possible and/or obligatory properties. And reasoning and ontologies also allow reasoning and assigning restrictions on object properties and data type properties to classes. It becomes possible to infer memberships to different classes. So all these properties can be defined in a more detailed manner as well, because you can model to every property also inverse property, like for a subordination, a unit A has subunit unit B. This can be used for an inference that a unit B is subunit of unit A. And this also works for temporal subordination. If you define unit C has assigned unit D, then unit D also is assigned to unit C. Functional properties apply if a unit has commander, for example, just one person. Then there are also transitive, symmetric, antisymmetric, and reflexive properties. Like transitive is part of property, like A is part of B, and A is part of C leads to the to the information that A is also part of C. And symmetric relations are like has the same affiliation as. So if you say unit A has same affiliation as unit B, then the same property also applies to unit B has a same affiliation as unit A. Anti-symmetric would be as part of, because it's different to has part. And reflexive is a property that an entity that holds that property always holds it with itself. So if a unit A has same affiliation as, then it also says that unit A has same affiliation as unit A. And properties that are reflexive, symmetric, and transitive define equivalent classes. And also to those properties, you can put even more detail. Like, for example, if you have a property that a supreme commander is commander of unit and you add all values from, then the supreme commander commands every unit that is defined in the ontology. If you say that a commander is commander of some values from unit, then it the commander just needs one unit to be commander of to actually be a commander. If you say that an action has a time instant exactly 1, then the action can only have 1 time instant to be true. And you can say that a location has coordinate at least 2, then it says that a location has some coordinates like longitude and latitude, and at most 3, that an altitude can be added. But actually, you can give those values, longitude, latitude, altitude, to both cases of that property. So what's the purpose of that knowledge representation? Well, it's important to have a database with a defined vocabulary to exchange between systems, so that no ambiguities can occur and no redundancies. And this knowledge representation also allows inheritance and reasoning for economic aspect in working, for example, or it can also be used to evaluate modeled knowledge. So now we come to the C2SIM core ontology. There, on the left-hand side, you can see a taxonomy, and the superclasses in this taxonomy are C2SIM content, initialization concept, and message concept. And the initialization concept covers all the information about initialization, like MSDL did, and message concept is about the C2 view. The C2SIM content also provides information that initialization and that the commanding structure needs. So, for example, platforms are defined under entity, which is a C2SIM content. And on the bottom of the right-hand side, you can see properties that I just talked about. And on the bottom, the properties are inherited by its superclasses. So you cannot see if has entity descriptor is a property that was inherited by actor entity, or C2SIM content. But when you click on these classes, you will find out. And if you create a new subclass, then you can add more properties, which you can do on the top of the right-hand side, like it has current state or has marking. Defining messages, we can see that in the core model, there are, on the one hand, system messages like C2SIM initialization body, but there are also communication messages like order body or report body. And report or order body has always a receiver and always a sender. And also an order ID, a requesting entity, and a task. And what we can see here is that the task of an order is defined at another position in the ontology. So on the right-hand side, you can see another screenshot with task. And here in the task, there's everything defined, like a task name code that refers to attack, move, or something else, and also a performing entity of a task, a duration, a desired effect code, an affected entity, and so on. Okay, so now we come to the standard military ontology. In the military ontology, There are also military organization defined, like unit, force, and so on. And we had also platforms defined, like aircraft as well. So, and we will need this aircraft in our extension, but we will add even more information to that. In the standard military extension ontology, there were also more messages defined, like the observation report content. And here it's the same as before, that the message itself is defined and modeled under message concept, but the observation is under C2SIM content, so that actually the initialization concept could also link information to that. Yeah, and the observations are divided into activity observation, health observation, location observation, name observation, subject type observation, and all have two properties added, like the confidence level and the uncertainty interval. So on the task side, the land operation extension also had specific tasks. The task also always need a task name code, and in the land operation domain also a functional association with another task, so it's linked to another task, and also task functional association code. So now we come to the air operation specifics that we want to use to develop an own standard and an own extension. And there are some specifics about air operations. For example, that airborne entities move fast, and they don't send position reports like usual units, but automated position updates are generated by an airborne radar picket system like an AVEX. And all this data that is collected forms tracks, and those tracks are referred or assigned to by track numbers that are used for units, but as well as for observations and targets. Messages are exchanged as TDL messages, and TDL is another a standard, the technical data link. And for messaging, we need to define a secure data network, as messages in this context are also broadcast. So for initialization, we need to define a secure data network and its participants. So it's under the initialization concept, and we need to define a communication network UUID and a subject entity, as well as track numbers. And we also need to define airborne entities. And as I just said, in the standard military extension, there is the class aircraft, but what we found out is that we need to define another superclass, flying object, because we want to distinguish between rotary wing and fixed wing, like aircraft, so that we could subsume jets like Boeing, E-3 Sentry, Dassault Rafale, and so on under aircraft. And we also defined UAVs, which we need in our scenario. Yeah. So on the messaging side, we defined TDL PPI report content, for example, and the TDL PPI report is a position report. But as you can see on the right-hand side at the top, there are many properties that have to be added in the TDL context, like has speed, has TDL direction of movement, and so on. And whenever you need to add properties to a class, you also need to define a new subclass for it. So we couldn't just define position report content having more properties than in the core model or in the other extension standards, but yeah, we needed a known class for that. And for the tool to generate a schema out of it, we also needed to add another class, a sister class to TDL PPL report content, that is standard position report content, to distinguish between the normal one and the TDL one.
Were these problems because of the nature of the ontology or because of the XML extraction?
This is hard to say.
No, okay.
I don't know, but the tool didn't work at this point. So we defined some dummy classes to make the tool work. Yeah. Okay, but concerning tasks, we made an interesting observation, because there's a TDL mission code or a mission task, and this mission task comprises of many maneuver warfare task association codes, like ambush or attack or move and so on. And but we still defined a TDL mission code class, because the requirement was that we needed to have a fixed set that where you cannot add different classes or instances, and yeah, but there were some correlations to the core and to the land operation extension. So, oh, that doesn't work. Oh, wow. Okay. They are not working. Yeah, this is just a list of all the reports and orders that we implemented into the air operation extension, like PPLI and mission assignment. I just talk about, but we also had remote transmission, drop, internal detection, battle management, and so on. But I cannot recall the definitions of them. They are all in pink and green.
It's the same as the list on the right, but the ones that don't show up had a definition.
Well, these are all the definitions of the orders and reports.
But
so.
We will believe you that you had definitions.
Okay. Yeah, that was about the air operation extension, but we had second use case in the COMELEC project as well, and what that was about ground operations or land operations with UAV deployment. And here's a screenshot of our C2 system, C2LG, and the unmanned systems reported on position, status, or values they measured by their sensors, or they also sent images and video streams they have taken. And we created a kind of extension at this point, but well, it's yeah, how can I say? We don't need to define a new extension, because we are waiting for the land operation extension and the UAV extension that is to be modeled by the Italian side of the MSG 145. So at the end, we just want to propose some more extensions to their extensions. Yeah. So, and here are some rules for reports and tasks of those UAVs, and they are very close to CBML, so it's quite easy to extend the core and the other extensions, which was differently in the TDL context. We have also another use case at Fraunhofer FKE, because we had an experience with BML for fire worker support, where we also used UAVs to report and to support fire workers, because they, in this context, they also took pictures and sent position reports for incidents or accidents that fire workers could react to that. And so it's also possible to use the C2SIM standard without the standard military extension, and to use it in different domains as well. Okay, so after all the ontology stuff, we still want to get a schema out of these ontologies or all the ontology layers. And we had a tool that was provided by the PDG or Kurt Blaze. It was an extensible style sheet language transformations document that could transform the ontology to an XML schema. In the COMELEC project, the German side worked very closely with the French side to find all the requirements for TDL, and we used our TDL or air operation extension together with the land operation extension, because there were also some classes that we needed, and we didn't want to model it in a different way. So also we used the standard military extension and the core model. And well, we needed some tries to get to a merged ontology that also worked for the XSLT tool. But I will talk about that later. But in the end, we had a schema. And yeah, also the CISO PDG found that representing information in an ontology and also exchanging that information in a standard way with a schema requires compromise. They agreed to constrain C2SIM ontology features somewhat in order to allow the schema resulting of a transformation rendered possible by the tool developed by Kurt Blaze, and achieve a workable standard in a reasonable time. We also wanted to show not only that we can extend the core model, but also that we can exchange the schemata that resulted from the ontology layers between our systems. So this is the architecture of that demonstration that we want to show at the ITSEC 2019. And well, with the automatically derived schemata, we had an executable scenario, and we exchanged messages between a direct CGF as a simulation system and the C2LG GUI as C2 system, and we use the Ellipse server of Airbus for that. Okay, so now we come to the lessons learned. Since this is a project in which different members have different expertise, we learned from each other a lot. So we learned a lot from our colleagues from the CISO C2SIM PDG and NATO MSG 145. Our FKE group, for example, learned a lot about air operations, TDL tracks, and how to represent all this ontologically. And we also learned some specifics on ontologies and how to build an extension to an already existing core and also to different layers. So we also found out that all the complex modeling techniques could not really be applied as the transformation tool cannot handle everything of it. Constraining classes, a class cannot be subclass of two different classes. in the tool context, like in vehicle as a platform or as resource, and that no equivalent classes can be defined, just one name for a concept possible, and that ambiguities can occur between object and data type restriction when you give both the same name, which the ontology tool allows, but it leads to confusion then in the schema process. And the object properties must have a range field, which is also not necessary for ontologies, but for the schema tool. And concerning restriction, we have the case that if a class inherits a property from its superclass, it might happen that the range for that property is restricted more closely in comparison to the property's range in the superclass. So for example, if a task has the property has task name code, so its range is an enumeration of all codes of all assumed tasks, like move and so on, the whole list of it. And if task has the subclass TDL class, TDL task, only the operation tasks, like take control, then TDL task inherits the property has task name code, but is supposed only to use codes that are codes for TDL. So adding a new restriction to the subclass has TDL task name code, which results in the schema in 2 lines that were redundant, or that one line would be redundant in that context. And in order to achieve a working prototype, we currently have not added restrictions to respective subclasses. Instead, we trust the users to only generate messages that are meaningful. And concerning the XSLT limitations, we have just 2 ways to handle it. We can simplify the ontology that can lead to information loss, or propose the PDG how information should be transformed into schema. But this is not always possible because ontology represents semantics and schema represents syntax, and these are 2 different issues. So, and what we also learned was that every step in the working cycle can affect other steps as well. So in the ontology extension process, many issues can occur if we define classes with different wordings that already occur in another layer. And sometimes the extensions or the core and the different layers, they don't lead to a merged ontology, because in the merging process, issues can also occur. And in the end, a merged ontology should result in a schema, and the schema should also check the information in the ontology if they have the semantics that the ontology intended. Ontologies have reasoning capabilities as well, and these reasoning capabilities are not handled yet in the C2SIM context, but the PDG plans to do that. And reasoning is important because reasoning derives knowledge from modeled knowledge. So a taxonomy actually does not have to be modeled manually, but correct and complete definitions of restricted classes will automatically be subsumed under the right classes. And reasoning in the C2SIM context can also be used to check unit hierarchy, for example, in messaging, or check entities and their capabilities, or check if messages are semantically complete, and check if they are semantically consistent. So the conclusion of this work is that we were able to abide by the core and standard military structure when we developed the operation extension, which was really hard because TDL doesn't rely so much on CBML, but has an own structure, but still we managed this. And we merged the core ontology with the standard military extension and the air operation extension. We were also able to automatically generate a schema out of the merged ontologies. So the process was to get a schema out of the ontology as proposed by the PDG was evaluated. And we created a schema that works for our systems, for the C2LG GUI and for direct CGF. And the evaluation of the exchange of messages between those two systems will be demonstrated at the IITSEC 2019 Orlando. So this is all the literature that has all the extension stuff and the transformation stuff as subject. And that's it.
I have more comments than a question. I would really like to make sure that the material out of your paper on the lessons learned gets into the guidance document.
Okay.
So I have a question because we already talked about your work and it's quite impressive. But Magdalena, how easy or difficult was it according to the current standard description? I mean, as it is currently, is it enough understandable for a newcomer to make the job, or it clearly needs strong support from the team of C2SIM?
Well, I joined most of the teleconferences from the PDG, so I don't know if only the paper stuff is enough to understand this. But from my experience, I can say that many people don't understand ontologies if they don't work with it, and that they think that they do, and they model it in as they think it makes sense. But from the ontology view, it's different. So I think that you first have to learn something about ontologies, and then about the different point of views from the systems, and then you can merge all the knowledge together. So basically, I don't think that just one person can handle all of this without support.
Okay. So I guess according to what you just said, it means that there are some recommendations that are not only technical, but also in terms of organization to set up, to ease the development of dedicated extension.
Yeah, and for me it was very difficult not talking to DigiNext, but creating a database that their systems can work with when I didn't work with the system themselves. So there are people with different expertise and all have to work very closely together. So it's not so easy.
Then I know that you are working on the OX for the other scenario, the German scenario with NGCS. What is the main differences between the way you are using and the way used by PGG?
Well, I don't think that there's a difference, because it was very easy to extend the land operation extension with UAVs, because there were just a few platforms, but the message style were the same.
Is it because Fabio is also some such kind of, have you been able to use the Fabio extension directly to?
I don't have his extension, but I learned some things from him, because he told me that he started with the schema he wanted to define the ontology, and not vice versa.
But I guess the main differences between the TDL operation and the MGCS extension is that you didn't start from MGCS standard. So as you mentioned, you started already with the schema, and based on that, and you try to make the things match.
I did it with the operation extension as well, and this was very hard because all the reports and orders were very different. They didn't have just one thing for who, where, what, and so on. But let me check. They had so many other properties, like has speed, has TDL direction of movement, has TDL environment, has TDL, and we took that TDL to show this. And when you go to TDL battle damage status report, this is just a screenshot, but there are completely different properties on the side. And if you have a look on the tasks in the core model and the land operation extension, you just have a task with all the same properties, and the restrictions on the classes can refer to different instances of them, but they still have the same structure.
Yes, but I guess this is the real life what you have faced with the TDL and UAV. From my perspective, it was more or less a shortcut of the real life, because you didn't take into account, in fact, the current protocol between the UAV and the ground station. I mean, when you get from Fabio, you get the things that were already an abstraction of that.
Oh.
And due to the fact he's an army guy, I mean, he makes the things much more green on top of that. So I guess he has already made the job of developing the abstraction. And when you wanted to make the job with the TDL, you have already a Stanag to face, and you have to deal with that. And nobody made the job for you before.
Yeah.
So I guess that's the reason why it was so much difficult. But I guess it's a real life, because if we want to make C2SIM a reality in the future, it means that clearly the issue you face, I mean, the other will face exactly the same, because nothing is made already today to cope exactly with the C2SIM concept. So I guess your lessons learned are much more critical, and the first one we get from the community. And that's why I was. My understanding is that it's not only a question, a technical question, it's also a question of organization. So we need to clearly separate the variables in order to have people well expert in the different domains. In fact, and you cannot cover every domain by your own. And this is many of the difficulties.
Yeah.
Other questions? Well, thank you for a very informative presentation.